In today's video, I'll show you how to make an app for the iPhone by creating a simple two-player rock, scissors, paper game. Before you get started, let me first demonstrate you how it works. As you can see, the screen is divided in half to distinguish between the two players. The game always starts with player 1. Player 1 chooses one of the three moves without showing it to the second player. As soon as player 1 made his choice, his move is hidden, such that player 2 cannot see what he chose. The second player can then make his choice and the app will determine who won. In this case, player 1 won because rock beats scissors. But there are also other cases we need to consider, such as player 1 loses or both players choose the same move, which would then lead to a draw. At the end of each round, they have the option to retry by using this retry button, and they can start over. Now, this is a very simple app, but you will learn a lot of concept and further can modify or improve the app to make it your own. Without any further ado, let's get started. Alright, now before we get started, open up Xcode and make sure you're running the latest Xcode version. At the time of the recording, it's 11.6, but any greater version would also work fine. Now go to File, create a new project, and make sure you select the single view app. Let's give it a name. I will just name it RSP Game. Also make sure that the language is set to Swift and the user interface to SwiftUI. Continue by pressing Next. I will just save it into my developer folders, but you can save it wherever you like. Alright, now once we're here, make sure that you choose the iPhone 11 as your simulator. And go to your content view and click resume on the automatic preview. Let's zoom out a bit so we can better see it. Alright, perfect. So as you can see, the first thing we have here is the rendering of the label, which comes from here. So if we would do any change here, you would automatically see it mapped here as well. So this is fine, but what we actually need is some kind of splitting between the player 1 screen and player 2 screen. The way we are going to do this is by creating a vertical stack initially, and inside of the vertical stack we will have two Z stacks. So let's start by creating a V stack. We will just replace this label with a vertical stack just like this. Inside of that vertical stack we will have two Z stacks like this. Now let's just put a color in here so we can easily distinguish them. Nice. Now let's also create a label for both players. So let's call this one player 2. And similarly, we will do that on the other stack as well. And we will name it player 1. Notice that the order here matters. So if you would put the text label before the color, you won't be able to see the text. This is because a Z stack basically allows you to stack items on top of each other. Now later on, between those two Z stacks, we will actually have our retry button, but I will just create a to-do here so we can continue with that later on. Let's name it retry button. All right. Notice also that we have some white space here on the top and bottom. The way we're gonna get rid of these is very simple. All we have to do is add a modifier called edges ignoring safe area. And we will pass it an array of edge sets. So the top and the bottom. Perfect. Now I would also like to change the label a bit. First of all, I would change the color to white. So we can do that by saying foreground color for the text is .white. But notice we have to repeat code here, and we should also copy and paste it here. But there's a nice thing you can do instead. You can just copy this and paste it to the parent stack, which is the Wii stack. And then both of them get it automatically, which is nice. Let's also change the font. I will just use this custom font, but feel free to use any font you like. Let's also give us some space by closing this right sidebar. All right. Next, what we need to do is show the 3 options that each player has. So for player 1, it will be here at the bottom, and for player 2, it will be on this side. But I just noticed we forgot one thing. We have to rotate this whole view so that player 2 can actually see it. But this is actually quite easy to achieve. All we have to do is find this Z stack for player 2 and then apply a modifier that is called rotation effect, which takes an angle. We will give it an angle that is initialized with degrees of type double. Let's say 180 degrees, and there we go. Now, to create these 3 buttons, rock, scissors, paper, for both players, we would have to copy and paste a lot of code. So there's a better way to do this. But nevertheless, to get an idea of how our layout will look like, we will just create a button for player 1. Let's just do it by initially creating a horizontal stack. Inside of that horizontal stack, we will have a button. Now we won't define an action yet, but let's continue with the label. We don't need all of that boiler code. But inside of here, we have our emoji, which you can access by pressing Control, Command, and Shift. Let's just use this emoji for now. And yeah, now it's overlapping, and this is because we are inside of a Z stack. But the way we're gonna solve this problem is we wanna have this color still in the background, but the text and the H stack in a vertical layout. So we will create a V stack. And inside of that V stack, we will copy all of this. And now we have the layout we like. Actually, one more thing would be nice is to have a space here. Perfect. Now we could just copy and paste it 3 times and do the same thing here as well for player 2. But this will just make our code unreadable, and we don't really want this. So a better way to do this is to start creating our Wii model and models and just use a for each loop for each option that we have. So in our case, it would be the rock, scissors, and paper option. So let's start with creating the model first. Now, usually you would create separate files for these, but for simplicity and so it's easier for you to follow, I will just put everything into the same file for now. Now, in our case, the model is the game logic, so I will just create a struct for now, and I will call it RSP game. Now, inside of that RSP game struct, I will have an enum that stores all moves that are possible. So we have the case rock, scissors, and papers. Now, what would be nice is also if we could set the corresponding emoji to each of these cases, like this. But in order to do this, we have to make sure that the enum conforms to the string protocol. Now it should stop complaining, and we can do the same for the other cases as well. Let's also make sure that the enum conforms to the case iterable. This allows us to get all of these cases, basically all of these moves in an array, which is very convenient. You will see later why it is so convenient. I would also like to save all possible winning moves that you can have, because if player 1 chooses rock, there's only one move that he can win against, which is scissors, because if player 1 chooses rock, he can't win against rock, which would be a draw. He also can't win against paper. So let's create a static variable for this. I will call it winning moves. And this static variable will take a key of type move and a value of type move as well. So let's return this dictionary. So in case player 1 has a rock, he would only win against scissors, right? And similarly, if player 1 would have papers, he would only win against rock. If player 1 plays scissors instead, he would only win against papers. Nice. So now we have the enum that represents all possible moves. We should also have an enum that represents both players. So let's create an enum called player. And we will have two cases in here, case 1 and case 2. What else do we need? We need to somehow represent the possible outcome or the possible results of a round. So for that, I will create an enum called result. And that result can return a win. I'm sorry. A draw or a loss. Now remember I told you making move case iterable allows us to access all moves in an array. And let's make it even easier. Let's create a constant called moves. And this will be move.allCases, and here you can see all cases gives us an array of all possible moves. This will be also nice in the Wii model later, so we can create these 3 buttons or the moves for both players in a for each loop, but you will see that later on. Now the game also needs to keep track of who the current active player is. To do that, we will create a variable called active player, and the active player will be of type player, and initially when we initialize the RSP game, it's always player 1. And we also need to be able to keep track whether the game is still on or whether the game is over. And the way we're going to define it is by the move. So there has to be at least 2 moves for the game to be over. It can't be that player 1 chooses a button, or let's say he chooses scissors and player 2 hasn't chosen anything, then obviously the game is not over yet. So before we get to that, let's make sure we keep track of the moves. And I will just use a tuple for this. So we will have a first move, which has to be optional because remember initially nobody has a move chosen yet, so it can be nil. Let's also create the second move and initialize them both with nil. Perfect. So now we can actually define whether the game is over or not. So let's create a variable called isGameOver, which is of type Boolean, and it's a computed property that basically returns true if the first move is not set and also the second move is not set. So we will say moves dot first is not equal to nil. Similarly, the second move is also not nil. Now we still have an error here. Let's figure out what the problem here is. All right, it says we have redeclared moves. Oh yeah, let's not call this moves, but instead call this one all moves. This will get rid of this error. Okay, now this should also work, and we always know when the game is over and when not. One thing we need to keep track of is the winner. So let's create one more variable. Which will be of type player. Now this also has to be optional, obviously, because there's always the case that we don't have a winner yet. Lastly, we need some kind of function to evaluate whether two moves lead to a win, a draw, or lose for player one. So let's create a function called evaluate result, and this function basically just returns an RSP game.result. Remember, that's the enum we defined here. And the way we're going to do it is, first of all, let's start with the case where we don't have a result, which can be the case if we don't have a first move or a second move. So let's do a guard let first move moves dot first and let second move be equal to moves dot second. Else we return null, because then we can't evaluate a result if we don't have at least two results. All right, make sure you enter the return key here as well. And that should get rid of the... Oh yeah, we have to make sure that the result is also optional. And that will get rid of this error. Now let's continue with the draw case. So when do we have a draw? Well, we have a draw if the first move is equal to the second move. So in that case, we just return draw. All right, so now we will take advantage of our winning moves dictionary that we initially created in the move enum to figure out if we have a win or loss for player one. So let's start by writing if let the needed move to win is equal to move.winning moves at the first move. And the second move is equal to that needed move to win. And remember, like, so when the player one, for example, chooses rock, we would go in here and check for rock, which would be scissors. So in order for player one to win, player two must have played scissors. So we have to check that the second move that the player 2 made is actually the needed move to win. And if that is the case, we can return win. Now, in any other case, we have a loss, so let's just return loss. Now, there's one last thing we have to do in this model before we can continue. See that this active players never really reset to anything else than player 1. What we're going to do is we're going to make this setting dependent of our moves. So let's make moves a computed property, and we will have some logic applied to it whenever the moves property is set. For example, if the first or second move is changed. So the active player will be reset based on whether the first move is not nil and the active player is 1. So if that is the case, we will change to player 2, and if that is not the case, we will change to player 1. And this will keep our active player always synchronized to the current state of chosen moves. Now we can continue and create the Wii model. So let's make a clear separation. This is still our view. This whole thing is our model, and now we will create the Wii model. I will create a final class for this, and I will name it the RSP game view model. Inside of this Wii model, we will have a private property. I will just call it model, and it will be the RSP game we just created. Now, what would be nice inside of this Wii model is to have access to all available moves that player 1 or player 2 have. So let's create a function for this. I will call it get allowed moves for player. So it takes a player of type RSP game dot player, and it returns an array of RSP game dot moves. So first we have to check if the player we're looking for is the active player. So let's do that by checking if the active player is the player that we got passed, and also the game is not over, because when the game is over, nobody has access to any of these moves, right? So if that is the case, we can return all moves, and otherwise we just return an empty array. So basically, if player 2 is not active, he doesn't have access to these moves, and also if the game is over, nobody has access to all of these moves. I'm sorry about that. We have to change this to is game over. So now we're done with this function. It would be nice to have some extra functions to initialize the labels, the status labels. If you remember from the demonstration, we had the 3 dots in case where the current active player is playing and player 2 is still waiting. Or we also had this label where it said you won, you lost. Now I also created 2 helper functions that will help us with the labels. I will just paste them in now and explain you what they do. So here we have a function called getStatusText, and it basically gives us a string for any player 1 or player 2 in our game. And what it will do is initially it will just check, is the game over? If the game is over, we will continue here. If the game is not over, we will check who the current active player is. If that is, for example, player 1, player 1 would not see the 3 dots. That label will also be used to print out whether player 1 won or lost. And lastly, we also have a function called getFinalMove. It takes a player, and then when the game is over, it will switch based on whether it's player 1 or player 2, and then it will check if the game is over. So it could be any case really. It could be a draw, it could be a loss, or a win. In any case, we want the raw value. Remember, the raw value would be the corresponding emoji of a move. So we just want to see the result. So that's what we are printing out here. And similarly, in case this function is called by player 2. Lastly, we also need to be able to tell whether the game is over or not, so that we can present the reset button. So I will call this function as game over. It returns a boolean, and it basically just returns the state of the model, whether the game is over or not. We also need a method that basically allows us to choose a move for both the player 1 and player 2. So we will create a function called choose, and it will take a move of type rsp_game.move for player of type rsp_game.player. And what it basically does, actually let's make a print statement so we can also see it locked. So I would just say player chose move. Okay, so this is just for us to understand what's going on whenever a player makes a choice. So what is the logic? The logic is we check if player is equal to 1. We will say model.moves.first is equal to the move. Else it's player 2, obviously, because we only have 2 players. Then we will do the similar thing, but instead of first, we will define the second with move. So this is all we need for the choose functionality. What we also need is a possibility to reset the game. So let's create a function called reset game. And to reset it, we have to do a few things. We have to first make sure that the active player is reset back to 1. We have to also make sure that the moves are reset to nil. And lastly, we have to make sure that the winner is also reset to nil. So we're pretty much done with our Wii model, but there's a few more things we have to do to make sure that the view basically stays synchronized with the Wii model. So in order to do that, we have to make sure that the RSP game view model conforms to the protocol observable object. And we also need to mark this model property as published. So this basically allows us to keep the view always updated. Whenever the model changes, the view will automatically refresh and replace the old content with the new content. So after we're done with these two things, there's one more thing we have to do. We have to go to the view model. We have to go back to the view, and we have to access the Wii model as follows. We need this key observed object, and then we will create a wall. I would just call it Wii model, RSP game Wii model. All right, so now we have access to the Wii model inside of the view, and we can actually use it inside here as well. And whenever some changes happen, the view will automatically update correspondingly. Let's first get rid of this button here. What we will do instead now is create a for each. And we will use our Wii model that we just declared to get all allowed moves for player 1. Also make sure that you pass in the ID, just like this. And in here, we can remove this, but what we actually get here is the move. So now we're inside of the for each loop and have access to each move of the array. Now we can create the button as follows. So the action is going to be self.viewModel.choose move for player 1. And the label is going to be text with move.raw value. Remember, this will give us the emoji as a string. Let's also create some spacers on top and bottom. All right. Now we need 2 more labels. Remember, we had first of all the 3 buttons here. That's what we have done with the H stack. And above these this H stack, we also have a status text label. So it will be the 3 dots. It could also not appear in case the current player is active. And above this, we also have the final move. So when the game is over, the emoji is presented here as to represent the last choice. So let's create a new text in here. And we can use these helper methods we just created in the Wii model. So we will say get final move for player 2. And then we will have another spacer here. And then we will have the text for Wii model get. So we will have the status text as well for, oh, I'm sorry, it should be 1 here. All right, so now that we have this, we have to also do this for player 2. So let's just copy it. So we need this all the way to this. Oh, we also need the spacer. And then we paste it in here. And obviously we have to change the argument to player 2 for all of these. So let's do that quickly. All right. Now remember, we still have this to do here. We have to create the retry button. So let's do that right underneath it. The way we're going to do it is we're going to check based on the Wii model property, is game over. In this case, it's a function, but yeah, so we create the button when the game is over. And what we're going to do is we will simply call reset game when the button is pressed. And we also have to name the button. I will call it retry with the corresponding emoji. Now I would also like some change some attributes here. So I will want it to be blue. I will also add a custom font here, but you can choose any font you like. To make it a bit more aligned and easier to read, we will do one more thing. So wherever we have the Wii stacks inside of the Z stacks, what we're going to do is create a small padding at the bottom, just like this. And I will just give it a padding of 40. And similarly, we have to also do that for player 1. Now this is not really necessary, but it just makes it look a bit nicer. Oh, I just noticed we forgot one thing. We have to make sure that everything after the color is inside of a Wii stick, similarly to what we did in player 1 screen. So let's quickly do that. So we take all of that and copy it into the Wii stick. And now we can create the padding similarly to the one we did for player 1. Now let's run this on a real simulator and see if everything works as expected. So it's player 1's turn here, and we choose one of these moves. As you can see, we see the 3 dots here, and usually you would also have this label here, but you don't see it because in this case for player 2 it's empty. So if player 2 now chooses scissors, he would lose because rock beats scissors, right? Let's retry. The retry button works as well. Let's try the case where we have a draw. Nice. So as you can see, it works just as expected. Now, if you like this tutorial, make sure you subscribe, and I will see you in the next video. Thank you for watching.